All right, let's begin the next section by understanding how the derivative can help us with graphs. There's something important to understand about the derivative. As we know, the derivative is the slope of a function at a point, and what that means is that we can tell, just based on the derivative, when a function is increasing or decreasing. Here's the idea. Pretend that I have a function, f of x, and pretend that this function has a derivative. In other words, pretend that the function is differentiable. Well, then that means we can tell when it's increasing and decreasing by looking at its derivative. This is called the first derivative rule. The idea is quite straightforward. If our derivative of our function is greater than 0, in other words, if our derivative is positive, then that means the graph is increasing. The original graph is increasing. Likewise, if our derivative is less than 0, then that means the original graph, f of x, is decreasing. And finally, if the derivative of f of x is equal to 0, then that means that at those points the graph has a slope of 0, or the graph is constant. We can use these ideas in order to tell when a graph is increasing, when a graph is decreasing, and we can also find relative maximum and minimum points. It turns out, and I'm not going to prove it right now, but it turns out that all relative maximums or minimums have to occur at points where the derivative is 0. And that kind of makes sense, because when the derivative is 0, that means we're either at a minimum or it means we're at a maximum. And so it would kind of make sense that the derivative point would be, the max or the min would occur when the derivative is 0. So let's take a look at a function and use this in practice. So here's the idea. I've got a function f of x equals x squared minus 4x plus 2. And we're going to go ahead and take the first derivative to find out if there's any relative maximum or minimum. So let's do it. So first off, we take the derivative. F prime of x is equal to 2x minus 4. In this case, because the 2 just comes down, the derivative of negative 4x is negative 4, and the derivative of the constant is 0. So we got 2x minus 4. Now, let's go ahead and find where its relative maximum and minimum are. We do that by just setting it equal to 0. And then we solve for all values of x. So we have 0 equals 2x minus 4. I'll do plus 4 plus 4. 4 equals 2x. Divide by 2, divide by 2. And so we get x equals 2. So that means we have a relative maximum or a minimum at the value x equals 2. In fact, let's go ahead and find out what the y value is by plugging in and getting f of 2, which will be 2 squared minus 4x plus 2. So that'll be equal to 4 minus 8 plus 2 when we plug it in, which will give us a value of negative 2. So our special point on this graph is the point 2 comma negative 2. Now, how do we tell if it's increasing, if it's a maximum or a minimum? Well, there's one thing I left out of the first derivative rule, and that's the following. So this is the first derivative rule continued. We have a 0. If you have a 0, then that probably means it's a relative maximum or a minimum. What you do is you want to look at a point before your 0 and a point after your 0. If the first derivative goes from negative to positive, then that means you're looking at a minimum. And you can kind of see why that would be, because our graph would be decreasing, then we hit the 0, then increasing. On the other hand, here's our 0. If the first derivative goes from positive to negative, then that means we're looking at a maximum. And that kind of makes sense because our graph would be going up and then going down. And so that's when a maximum occurs. So let's go ahead and check this out. So once again, our derivative was f prime equals 2x minus 4. So we know our minimum or maximum occurs at 2. So let's find out what f of 1 is and f of 3 is. And when I say f of 1 and f of 3, I mean f prime of 1 and f prime of 3. Let's see what those two values are. So if I plug in 1 into this function, I get 2 times 1 minus 4. And if I plug in 3, I get 2 times 3 minus 4. So that's going to be negative 2, and that's going to be positive 2. So in this case, before our 0, we had a negative slope and then a positive slope. That's this one right here. We had a negative slope of negative 2, 0, then a positive slope. So that means that this is a relative minimum. And that's all there is to it. It's pretty straightforward. Let me know if you have any questions. In the next video, we'll look at a couple more examples.